Here the square modulator generates a signal phi of t that is equal to AC m of t cos omega ct plus theta. Sketch the amplitude and phase spectra of phi of t for m of t is equal to triangular 200t. Okay, let's see how to do this. So here they have provided triangular 200t, and we can rewrite this one to find out the bandwidth. So here triangular to find out the width. Okay, so here triangular t, and this one is also equivalent to 1 over 200 in the bottom, because if you put 1 over 200 in the bottom, that flips around and go multiply the top. So we can represent this one by representing this. You see the width right away, like 1 over 200 is the width. Okay, whatever the value below t will be the width. So here 1 over 200, that is the width. So if you draw the graph for it, okay. So this is a triangular. It's a triangular with a width of 1 over 200 from the origin. So it's gonna have a negative 1 over 200 and also a positive 1 over 200. And this is triangular pulse. And this one is m of t, and we are writing with respect to time. Okay, so this is the graph for the given m of t. Now in general, so here we are going to do the Fourier transform of this. In general, we are going to see some properties. Triangular of t, the Fourier transform of triangular t is sinc square f in the frequency domain. Sinc square of f, and triangular at, the Fourier transform is one over a sinc square f over a, and this is a scaling property. Okay, and triangular 200t, the Fourier transform is 1 over 200 sinc square f over 200, and that is m of f. So this is the one given to us. So if you do the Fourier transform of that, that's 1 over 200 sinc square f over 200. Okay, and then given signal here, phi of t is AC m of t cos omega ct plus theta, and we have m of t is given, so we have to just plug it in this equation to find out the corresponding signal. Okay, so this is this. So phi is equal to AC m of t cos omega ct plus theta, and then AC m of t, and cos omega ct plus theta, we can write this in Euler's identity like this: e power j omega ct plus theta, and then plus e power minus j omega ct plus theta over 2. This is for cos. Okay, so from this if we multiply this one with this, we are going to get AC over, I bring the 2 here, so AC over 2 m of t, and then we have e power j times theta, that's j theta, and then times, when the power add is multiplication, so times e power j omega ct. Okay, that is the first part of it, and then we do the other part, that is also AC over 2 and then e power minus j theta times, and I forgot to put the m of t, so let's put it here, m of t, and then e power minus j omega ct. Okay, so this is the expansion of that one. Okay, this is the expansion of that one, and after that, here we can use one of the property, that is frequency shifting property, using frequency shifting property. X of t, if you multiply an x of t with e power j 2 phi f naught t, then the Fourier transform of that one is in the frequency domain, this one become x of f, and also we will have a shift of whatever the frequency that is with power of e power. So here in this case f naught is a e power frequency here, so this is going to be shifted to that, then that's going to be the Fourier transform of this. Okay, so we are going to use that property in this one and make it symbol, and let's do that. So this is phi of t. Now let's look at phi of f, that is Fourier transform of this one, that is going to be AC e power j theta divided by 2, and then we have only this variable and this one value related to t, so when we do the Fourier transform, these are the things that's going to be affected. So this one is t, this one is omega ct, and as you see, if you have a t, that turns into f, and then whatever the shift we have, so here m of t is going to be m of f and this one is omega c. Omega c is equal to 2 phi fc. Okay, so the frequency we have here is fc, so this is going to be shifted f minus fc, and then plus AC by 2 e power minus j theta, that is this one, and then this one also shifted okay. So here you have to be careful, this is negative omega c, so here you see when it's positive we get a negative here, if it's negative then this is going to be a positive, because minus minus that turns into plus, so this is going to be f plus fc, and then that is it, and then plus that is it basically. Okay, now we have done the shifting like that, this whole thing become a shift. Okay, and we do that with m of t, and that is it. Now we can do one more thing, that m of t is a function that is this, triangular of 200t. That's the m of t provided in the question. If you look at here m of t is equal to triangular 200t, and we already did the Fourier transform of that one over here. Okay, the Fourier transform of m of triangular 200t, that is 1 over 200 sin square f over 200, that is m of f. Now we have m of f plus fc, we have shift. So what's going to happen is this f terms is going to be subtracted like this and also added like this. So we can plug this equation instead of m of this function, only the shift should be added. Okay, so if we do that, I'm going to create a new page to do that. So if we do that thing, then this is going to become ac over 2 e power j theta, and I'm applying the m of f function, that's 1 over 200 sin square, and then the shift f minus fc 200. I just put this value, but it comes with the shift because of this. Okay, because of the shifting property we used. Okay, and the same thing go to the other side as well. That's ac over 2 e power minus j theta, and then 1 over 200 sin square, here f plus fc over 200. Okay, that is it. From this one we can just draw the diagram. So here the question is asking, sketch the amplitudes and phase spectra of phi of t of this one. Okay, so now we have the signal of phi of f. We can go ahead and draw the diagram for it. So here what is important is we had to know where is the center of this one located at. That one you can right away from this one you can see that this is shifted fc to the right, fc to the left, so it's going to be centered at fc. So here this one is going to be at negative fc, and the other one is at positive fc. Okay, this is at negative fc and this is at positive fc, and whatever the value you're dividing, that is the width. So it's gonna be, this is gonna be a minus 200 minus fc, and this is gonna be plus 200 minus fc, and then this is going to be minus 200 minus fc plus 200 minus fc, and this is fc minus 200, and this is fc plus 200. Okay, that's all we need. And this one is diagram of phi of f, and the height is a by c, and this one. Okay, so here the amplitude is a height, but here also we have 1 over 200 and then this 2, so totally we have 1 over 400. AC over 1 over 400 is the amplitude, so that's going to be the height. Okay, and this one is a frequency domain picture. And then phase angle diagram. Phase angle is just 1 for this. Phi of f, phase angle, and this is 0, and this one is at minus theta, and this one is at plus theta, and then this is in frequency. Okay, and that's all for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on